Hey everybody, this is Brian. Welcome to the 10th Python tutorial. Man, we are just hauling through these. Call it Python 10. And what I want to cover today is exemption handling or error handling. Obviously, you've seen me make a few mistakes, and I'm sure as you've been following along, you've made a few mistakes. So how do you handle those mistakes? Well, we use what's called the KISS method, which is keep it simple and stupid. Or simple/stupid. And what does that really mean? It means don't complicate your life any harder than it has to be. So we're just going to say def do something. And let's say we're going to n equals 0, x equals 5, y equal, let's just get creative here, x divided by n, print the value of y, just something generic here. And then we're going to, totally forgot our little brackets. That always bites me for some reason. Just so we can see that we're starting the program, and then we're going to do something. And let's run this and see what happens here. Oh no, we have an error. Shocker, we're dividing by 0. Well, this is a standard error message in Python, and I'm sure you've seen these before. And this is called the trace back, and what it does is it starts where the error originated. So like if we just go line numbers, line 13 in module, which means in the current module. If it was a different module, it would give you this module name would be different. All right, so line 13, do something. So we know instantly it's coming from do something. But it goes a step further and says line 9 in do something, and it gives you the actual code that's calling the error, line 9, this guy right here. And it gives you a description, 0 division error, division by 0. If you've taken any sort of rudimentary math class, you know you cannot divide by 0. I'm horrible with math, and even I know you can't divide by 0. It's just not possible. You can't do it. All right, so how do we get around this? Like, let's actually say number, and let's give the user the ability to enter the number. Right? So we're going to run this. What do we do again? Oh yeah, derp. All right, so we get 1.1. We can change this, so we know our function's actually working. 2.5. So we're going to take whatever divided by whatever. Now, if the user enters 0, we're back to square one. We're going to have that same error again. We don't want that. So we need some sort of exemption handling, and it's in the form of a try exempt finally. And we're going to explain that. Say try, and we're going to indent this code. Notice how it gives you a little squiggly when you use a try. It's expecting an exempt or a finally. First thing we're going to do is accept, sorry. And we're just going to accept exception as E. And this is what's called a catch-all. And let's make that a little prettier. Something went boom. Now what try and accept does is it'll try this code, and if something bad happens, like a division by 0, it'll run this code because this is a catch-all. This will catch any exception out there. So let's run this. And you see now it says something went boom, division by 0. So we have a nice, pretty, something happened. And E is actually an object. So you can actually get into the args, you can do the traceback, you can do pretty much whatever you want. You can get the actual base memory on that. So it makes it a lot easier to work with. And notice how it didn't kill your program. Even though there was an error, your program keeps chugging along happily because you encapsulated it within a try except. So that's one way of doing that. Now a finally is a little bit different. Finally will always execute, regardless of what happens up here. Notice how Y never prints because we had a division by 0 error, but if we run this, you'll see finally I get to run. So even though there was an error, finally will run. And you don't necessarily need this code. You can just do a finally. You can do try finally. You would do this for the example if you had a file or a database or some resource. You would open it, and then when you're done in the finally block, you would actually close that resource regardless of whether or not you had an error. Now, as you might have guessed, if you're been working with other languages, you can actually classify exemptions. So we'll say 0 division error. We'll say please do not divide by 0. And let's get rid of that. Now when we run this, notice how it says, please do not div by 0 instead of the catch all, because we've actually specified we want to catch 0 division errors and do this block. General rule of thumb, catch-alls are bad. You want to know what sort of problems are rising in your application. Another thing you should never do is simply pass. For example, runtime error, and we'll just say pass. If we've never covered pass before, what pass does is it just does nothing. It just takes the execution context and jumps right out. That'll create what's called a silent error. Well, actually, it'd been a better example if I had just done it in the division by 0. Let's throw a pass in there. Let's comment that out. There we go. That's what some people will do. They'll say if you divide by 0, just pass. That creates what's called a silent error. You never knew that happened. You never, 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 never want to do that. Repeat after me. Never do that. Reason why is because you want to know that error occurred. You want to do something with that error. You want to either log it or correct the problem. For example, please do not div by 0. You're telling the user, hey, choose a value greater than 0. One thing you should really understand about error handling is that you don't want to go completely crazy. As you can see, the error handling actually is bigger than the algorithm that we wrote. That's called defensive programming, and it's good to do that. But you don't want to make an exemption for every single type of runtime error that's possible, and there's a lot of them. So if we go out here, I was wondering what was that. Oh, stocks, never mind. If you go out here, you can see that there are a bunch of exemptions. And you don't want to make one for each and every one of these. For example, you don't want an OS error in that algorithm we just wrote because we're not dealing with the operating system. You don't want a stop iteration error because we're not dealing with it. So you kind of got to look at your code and say what really is going to happen here. Well, division by 0 is completely possible. But I would always, as a rule of thumb, put the catch-all in here, because if you don't and something else happens, you're going to get a runtime error. For example, let's do this. Let's just comment this out. And let's actually do, let's say we just expect a runtime error. And we're going to say print. This may not be the best example. Actually, it's not. Let's do OS error. There we go. Now let's run this. You can see how now our program crashes because we never captured that division by 0, either this way or with our catch-all. So you're going to want, at a bare minimum, a catch-all statement. Something went boom, division by 0. But it's always better to know what kind of errors you're getting into. That way you can handle them appropriately. Whew, that was a mouthful. It's been a long day. Thank you for watching. Please feel free to visit my website for the source code for this and other tutorials. Just go to Python, and I'll upload. I just did a bunch of videos. I think I did like 4 or 5 videos right in a row, so I'll upload all those before I go to bed tonight. Hey kitty, Daddy's recording. Yes, I know, you're hungry. Visit Facebook and join the Void Realms Facebook group. There's 200 of us out there that are eager to help. And if you do join, be sure to offer help whenever you can. Nobody's an expert in any one thing, but if you have information and somebody's asking for help, just jump in there and leave a quick comment.